Alright. Oops. Video, we're going to talk about failure and what to do about it. Now this is my original machine. Name is Morton. Very first prototype. It has been running. It's made probably over 1,000 prints. These are clearly the crack key lids. I've been iterating on them for the most part. And if you notice, there's this little commonality with most of these. The belt. This is again a failure of the belt. Basically the tape. Managed to catch the tape. And these, the machine tried to print on top of itself. That's not actually a failure of the belt, it's a failure of the ejection system. I always didn't really like how far this gear stuck out. Now, see how easy that was? It's not good. There's also quite a lot of play on this shaft. The first design of this, I was using a nut in there and basically a set screw to hold onto the D shaft. After about 500 prints, she snapped about in half. This guy had a D in there, and it's completely worn through because despite that, a single clamping pressure was not enough. I think we do need to use two to distribute it. Basically just as I on that. He's already got... Oops, that's the wrong part. Speaking of failure, he's already got a replacement. Another thing I'm trying is smaller gears, less force on the shaft. And I noticed this is extremely loose. There's quite a lot of play in this motor. So I got a larger motor with a spur gearbox instead of a worm gear. This video, I'm going to take this apart to see why this guy's so loose. I have not looked on the inside of him, so I'm going to do that. I'm going to do a short follow-up video on better ways to install the motor. I really like this sort of clamp system. I'm just going to go like that, because now I can actually rotate the motor to engage the gears. And I'm going to mount this motor on the shaft, or on the basically on the slot here. And instead of driving from the front, we eject to the front and drive from the rear. Found that I could get a shaft collar for the front that would be small enough that I could still remove my steel sheet, place it on top for printing without the belt. Things that need the best belt adhesion. Also trying out, found some thicker PET sheet for the bed. Using the thin clear sheet on Frankenfurter. This is twice as thick. I think we'll have enough force, and especially with the larger motor. Let's point out this is, well, it's a 500 RPM motor, but after the gear reduction, it's 20 RPM. On Amazon. Decent part. Alright, I'm going to take a look inside this guy, see what's going on in there, see what kind of support this shaft has. It feels real good, but of course I have not run this yet, especially compared to this guy. It's a very shallow D on the shaft though, which I'm not super fond of. If we can't get the clamping force in plastic with this, then the alternative would be to buy a metal shaft collar and simply screw the gear to a metal shaft collar. I think that would get me the most force, but I'd really like to have it all plastic, just faster to iterate. Faster to iterate, fewer parts. Okay, let's get this guy off. Actually, first thing we're going to do, I'm going to turn the printer off, because practicing safety is, worth doing. So I'm not going to do the assembly in this video, just because it'd be a little long. But we'll do some thoughts, and I've already done most of the design, so assembly should be fairly short after this. It's mostly I want to do some assembly on my own and see if my designs are worth their, you know, worth showing to the world. So, comparison, tiny motor, giant motor. Wow. This was a 20 RPM motor as well. It's just using a larger reduction on a slower motor is my assumption. Okay, grab a screwdriver. I also have not put any lubricant on this myself. This is all whatever came on there from the factory. Huh. So there is a worm gear, but it's absolutely tiny. And the rest of it is so covered in grease I almost don't want to. That's plastic, isn't it? Huh. Looks like an aluminum on there. Your paper towel on. So the output is that even brass bushing? Why have a dental pick in the first place? Can't even tell it's brass. But it looks like the outlet is just a bushing, not even a bearing. Not too surprising, this is a cheap gearbox, but still. Surprised to see plastic in there. Well, I don't feel like I'm going to be using that again. Probably put it back together later. Anyways, just should probably keep it around. It's for posterity. Is this better? Shinier. It's a bit more expensive. Well, all the gears are metal. They did us a favor of not using just the barest whiff of grease on there. There's some. And the output is definitely a brass bushing for the rear. Looks like a longer shaft. But I believe that's just a steel bushing as well. But at least we have a much larger bearing. It looks like a steel bushing. Hopefully hardened steel. Can't actually test that. I shouldn't be able to scratch it, but I also don't want to ruin something before I use it. I don't know. Can't tell if I think that's better or worse. But compare the distance. That is, you know what, 4mm? That's good. Yeah. Easily 6 or even 8, or easily 8 or even 10mm. We're doing a good bit better on this guy. Not as good as I was hoping, but we will try putting her in. See about it. All metal gears the whole way up. Just driving in that direction. Feel like I should throw a little extra grease in there too. Keep her smooth running. Alright, so failure analysis. Main things we take away from it is our front gear sticks out too much. Motor is underpowered. And if we can improve the tape, do a lot better. 2 ideas for this guy. 1, trying out different belt materials. Ones that'll stick to the tape better. I also ordered a bag sealer. See if we can actually fuse belts together and do a DIY belt at home. The other is, you know, purchasing belts from the right length from the real actual manufacturers. See how that goes. Alright, happy printing. Next step, I'm going to put this guy back together, do a test fit, make sure that this all works. I'll do a video on the assembly for you so you can do the 2.0, because we're basically replacing how the ejection system works. I don't imagine replacing any of the drive hardware, so the majority of this stays the same. And of course the control system is just a motor, hooked up the exact same way. Although, knowing me, I probably got the wires backwards. Alright, happy printing.